Good evening, everyone. It seems surprisingly awake to be the Friday of DevOps, I must say, and all of you. Welcome to this talk. I'm going to talk a little bit about how to test with Docker, or both testing Docker and using it for testing. So I'm going to assume everyone knows what Docker is at this point. Anyone who doesn't? Well, not many. So we're going to see how we can leverage Docker and the way it starts containers to help us test our existing applications, as well as testing things that are in Docker already, more like a complete Dockerized application. Anyone who don't know what Arquillian is? Okay, a good chunk of you. Okay, so then we'll go through a bit what that is. So Arquillian is, it's not a testing framework, it's a testing manager. It's a testing, it's a testing framework, not a library, is what I'm trying to say. So it's not trying to compete with JUnit, it's not trying to compete with TestNG and so on. It integrates with all of them and essentially they're just to handle the lifecycle management of different things. So it started out as a testing tool for Java EE, so it can handle the lifecycle of starting and stopping containers, for instance, and doing the deployment to them to set up the different environments. But it's built in a fairly extendable way, so it can be used to start and stop Selenium servers, for instance, or configure the Selenium drivers for you. It can handle the database setup, inserting data, and then having some helpers for you to be able to assert the state on your database easier. And there's about 30 to 40 different extensions that exist for Arquillian so far that touches upon anything within the testing space, essentially. We're going to just go through how Arquillian work on a high scale overview. This is how it works when you operate it on the Java EE servers. So the first thing you need to do is somehow select a container that you want to run this against. The actual container implementation is abstracted out, and there's support for roughly 50 or so different containers that ranging from things like the CDI container, or Tomcat, or Wildfly, Oracle, WebSphere, WebLogic type of things, but also just simple JVMs. So in the Arquillian world, a container is loosely defined as just something we can call up on this API that has a life cycle of start and stop, and potentially you can deploy something to it. So whatever anyone want to write as far as a container adapter, that's feasible to do. Okay, turn it off. Okay, never mind. So then the next step is to start or connect to that container, depending a bit on what type of container that is. It could be starting up a local instance of an application server as part of the test runtime, or it could be connecting to a server that exists in the cloud, for instance, somewhere, or in your local test environment. And then it comes into the packaging phase, which is normally where you want to define the scope of this test and the environment that is going to run on within this container. So typically in a Java EE application, that would be a web archive or enterprise archive or that kind of thing, but it could just as well be some form of generic archive that is started up in a JVM. And there's APIs to help with this, which is called shrink wrap, which can package down any type of resources, being classes or files or descriptors and all of those type of things from the local class path, and then bundle it up into a virtual archive, essentially, and then move that over to the container. And then one of the kind of key features of Arquillian when it comes to the application servers is the ability to then run the tests inside that container or inside that environment, as opposed to just purely on the outside. So when the test method itself is running, you actually have access to all the things that that target environment has, meaning you can inject database pools or connections, JVM connections, security managers, and all those type of services that are provided by the runtime. And then it's reporting back the things that happen in this server that could be anywhere in the world, essentially, and reporting it back through the test integration that is on the client side, and the results are passed back up through the same reporting mechanisms that are in all of these different testing frameworks. So when you run it from Eclipse, for instance, using the JUnit integration, you will see on the side the normal green bars, and same if you run it through Maven Surefire, for instance, you will see the normal Surefire reports and so on. So there's nothing changing it from that perspective. And then there's a cleanup phase. So that's kind of the basics of, for those of you who know Arquillian would know how that works. As far as the code is concerned, so this is an example of the JUnit integration. It starts on top there with the run with Arquillian, which is one of the JUnit extension points, essentially saying that Arquillian now do whatever you want to do and take over execution of this test. The first magical point is the deployment annotation. That's where you define the environment that you want to have this, or the target environment for your tests. And then there's SPIs within Arquillian to enrich then the test class instance again. So you can inject back, for instance, in this case, this CDI bean that is in the container. So that's the same instance as your application would see. There's no mocking or anything going on. And the test method would actually be running inside the container as opposed to in your IDE. So you can operate on those real objects. And then there's the kind of the client side view where you want to test things from the outside, that being a REST API or a HTML page or anything like that. Essentially just defining the deployment to be testable false, and then the content of that deployment is just deployed and the test method is executing on the client side instead. And here we're using rest assured to check for to check the response from a REST endpoint we have. And interesting features like the injection of the URL. So since Arquillian knows about the container and knows about the deployment, it can also tell you about where this deployment happened. So it doesn't have to have a separate properties file when you're moving from test to stage to production servers, for instance, or from your local deploy for that matter. So as far as adding Arquillian to your project, it's of course a Java project. So you add some Maven dependencies. We have a new bill of material POM that kind of describes the whole Arquillian universe of extensions in a coherent way. So you have dependency management, dependency on the Arquillian universe BOM, and then you include the different modules that you want. So Arquillian universe, Arquillian JUnit, or potentially Spock or Cucumber, JBehave, TestNG, or whichever other integration you want to use. Then a container integration to run against, for instance, a wildfly server. To sum it up, what Arquillian is, it's trying to remove anything of setup away from the test case itself, and trying to make them portable. So if you have a test case that's going to run in the cloud on a server or on a local server, being a wildfly server, and you need to test it on Glassfish, for instance, the idea is that the test case itself is going to be the same, but you can just swap out the configuration in the background. And yeah, it's executing from wherever you're running it from, so you don't have to go out to the command line, for instance, to be able to execute it. You don't have to wait for the whole build to finish. It uses the incremental compilation that it's happening in the IDE, so you're just packaging up the stuff that is found there and sending it off to the server instead of having to write a test in the IDE and then jump out to the command line to run and build Maven, for instance. It's a testing platform and not a library per se. It's handling the life cycle of things. That's its main goal. Yeah. So on to the first topic as far as testing Docker things. By the way, any questions around the first part? One curious to know more about Arquillian? If anyone has any questions at any point, just raise a hand. So I'll know. So Arquillian Cube is one of the many extensions that are in the Arquillian universe, and it deals with lifecycle management of Docker things, not just Docker with a big D, but anything Docker with a small d as well. So just as well Docker machine or the Docker daemon, but also OpenShift, for instance, or other Kubernetes-driven deployments. So you can use this for a couple of different things. We'll have a bunch of examples to kind of go through the different use cases of it. Let's just skip further on to that. Let's look at the first one. We're going to take out just a normal JBoss wildfly image, and we're going to start that up, and we're going to do some JPA repository type of tests on it. That's the Docker file, essentially. Not too much interesting. That's the test case. So we have some deployment. We're going to inject a repository that's backed by a JPA entity manager. And you can see the Arquillian persistence extension, for instance, the using dataset, which takes a YAML file with a defined data structure and inserts that into the database before this test method happens. And then we're just getting the strongest pair and so on, and just asserting the state on it. To get Cube into your project, you simply add from the Arquillian universe BOM again, just Arquillian Cube Docker, as opposed to Arquillian Cube OpenShift, for instance, if you wanted to run it on OpenShift instead. The Docker version supports both Docker machine and Docker daemon. Swarm is coming, but not quite yet. And yeah, the persistence extension, the container, and there. So as far as configuring Cube, in the Arquillian XML file, which is normally a file that you don't have to add too much to, but in this case, we're going to define an image that's called wildfly. And we're saying that we're going to use this specific Docker file that is found in the wildfly directory there. And we're going to bind some ports. And that's the only thing Cube essentially needs to know. So when it starts up, it will build that image, it will install it into the server, and it will start it. Then it has this special integration with the Arquillian container extension. So it will manage to map then the normal wildfly adapter on top of that newly started Cube. So you don't have to specify the ports, for instance, or the IP addresses that this Docker instance got, or the Docker container got. So let's run that first demo to just see how that looks. So I have a Docker machine up and running here. Let's see, do you see that at all? Make it a bit bigger. Oh. So there's nothing up and running at the moment. And this is the same test that we saw before, essentially. We're going through different things. Seems to have anything more interesting. Yeah. Just a bunch of tests to test the repository. So this is going to then run against a a wildfly server that is deployed as a Docker image. Run as JUnit test. And we should see the container is starting. And eventually when that's up and running and everything, we hopefully have green bars. There we go. So that's testing against the local database that is deployed within within Wildfly. And then when it's done, it's going to shut down and remove all the instances or all the containers and images that were created as well. So that's one simple example. The next one is, of course, the interesting part about Docker, and from a system test perspective, is the orchestration. So you're probably going to run with more than just one container. So out of the box, Cube supports discovering through delinking and so on that are happening within the Docker files, and can start up the dependent services in the correct order. So in this example, we're going to... It ties into the idea that as long as you have a Docker image, you don't have to have the external database installed on your own machine. It's easy to swap between different versions of the database, different types of databases, just by defining which image that you want to start as part of this. So the added configuration in this port in this point is we're now having 3 containers. Well, we're actually just using 2 of them, but we're saying that we're going to start the MySQL one through the auto start containers. So you can consider the idea that you're adding the latest version, you're adding MySQL 5, you're testing against the Postgres, and so on, and you just then control it through the configuration of this auto start parameter, which one that you're actually going to run against. So you can spawn out the test suite to run on multiple. This also shows off the extents capability of the Cube format, which allows you to have one default configuration and then kind of add on different permutations of them. And if some of you might have seen that format looks fairly similar to how Docker Compose looks, then we can swap that with Docker Compose as well, and just use the same or the same standard Docker Compose format. Historically, we made this part before Docker Compose existed, so that's why it's still not the default one. And there's a couple of things you can configure in Cube that you can't in Docker. It just depends on how kind of Cube works in general. So let's look at that as well. It's essentially not too different from the other one, except that we're using an external database this time. So when we run that as a JUnit test, this time we should see 2 servers come up. There. So it's starting the MySQL one, and it's starting the Wildfly version of it. So then we're testing against something external, and then it kind of shows off that you can start up these multiple containers as you feel free to. There we go. Any questions? Anyone not understanding this at all? No? Yeah, good. Good. So, containerless. What we've been seeing so far is the idea that Cube is starting up Java EE containers, essentially. Because, as I said, that's where Arquillian came from, and that's where we used to live. But there's also, when we have control over starting a Docker image, essentially a Docker image can be anything. So we expanded the idea of a container to be, well, essentially what I've been describing it to be for years, just something you can start. So the containerless container is a Cube container that you can deploy anything into. It takes a tar file and we'll put that into the Docker image. So if you need to test a node application or not container applications like Spring Boot or Vertex or that kind of thing, then or Go or any other language. The only added feature, or added dependency rather, is to add a dependency on the Cube containerless, and that's the only configuration needed. The example is a JavaScript application or a Node application that exposes a very simple REST API. And as far as the Java test is concerned, it looks about the same, except that we're now creating a generic archive on top there, and we're adding the JavaScript packages and the package.json file that that npm will use to install this thing. So when this archive is created, it's matched against a Dockerfile template that's configured in the Cube configuration. And the only variable you have is essentially the the deployable file name. So when a Cube starts up, it will place that file name into that add, and you can build the container however you want, and it will be waiting around, listening for the exposed port there to kind of start up, so it knows that this container is up and running. And on the configuration side of Cube itself, there's nothing special, except that there's still the Dockerfile location. Then you have the containerless container that's mapped to, in this case, just the only image that is there, which is the node one. So when the container starts up, it will invoke the deployment method, take the output of that, put it into a temp folder, execute the build, or sorry, the Docker build template file, and put that up on the server. So let's see how that works. Again, pretty much the same as before, but so yeah, see our little node application here again. Just testing the REST endpoints. We'll see how npm install does on this network, but there, npm install. Start, are you good? Ah, there we go. Green bar. So with the containerless container, you can essentially test anything that you want to deploy, or yeah, anything, as far as what kind of language and what kind of runtime. It's something that the Arquillian Cube extension doesn't really care much about. It cares more about that there's going to be an exposed port somewhere, and as long as you can find that port, then do whatever you want. So then there's container objects, which is the next thing. It's intended to be, if you develop a application or a container of some sort that is something that your project delivers, but someone is depending on that and they want to test against your container, then the container objects are essentially similar to how the page objects work in Selenium, but they allow you to distribute out the configuration and configuration and how to start a Docker container as part of a jar file, for instance, so that anyone else can reuse your configuration is essentially the point. So then we're moving over to the standalone version. It's internal Arquillian speak. It doesn't really matter in this case. So we have a container definition, which now has a cube Docker file instead of the deployment method, but it has APIs for allowing you to create the Docker file dynamically, or potentially import it, depending on how you want to do it, and then create some arbitrary tar file that you want to add to it. Based on that, when this thing starts up, you could then create an API around your application to, for instance, get the connection URL or other features that you want to expose to someone that is going to use your container. And you can, of course, inject back things like the host IP. You can also override the ports that are being configured in this thing from the one who uses it. So the container can also inject the host port and where it's running to have more control over it. From the client side, the only thing you do is say add cube and then the name of the container. And then when cube starts up this test, it will find this annotation and it will start up that container, and you have control over it. It will stop when the test is done. And here it's just a ping pong container that returns whatever we send it in. So it's not too interesting as far as the. And on the cube configuration side, the only thing you need to tell it is where is this thing going to run. So if you're not using Docker machine and using just the local Docker daemon, or you're using boot to Docker and everything is installed at default, you don't technically need anything at all. So let's look at that as far as test is concerned. Wrong one. Yeah, we're just getting the URL and checking on the response. This one tends to start fairly quick, so there we go. And done. And we have a green bar. So that's fairly easy and quick to do. And it gives you the ability to kind of pass around this predefined configurations of your containers to others to use, or for other test cases. And then the new part, which is even more fun, and this is the dash of chaos that was in the talk. Now that we have control over the machine or the machine or the daemon that is running all of these containers, we can also start to do interesting things like control the network around them. So a kubectl is an extension to kube, which injects proxy servers in all the different endpoints and reroutes the traffic around, or reroutes the traffic through itself. And then you can control in the test case that one of the servers is not going to time out, or it's going to be slow, or it's going to be down, and so on, to see how the rest of the application behave based on that. So the dependency is just kubectl toxic. It uses the toxic proxy underneath. And you can inject a Arquillian resource that is Q, and Q is the kind of the entry point to all of it. So you can say when this body is executing, make sure that server 2 on the route that is on port 80 actually will time out, or potentially have slow bandwidth, or yeah, all of the other options. And the configuration of our example here is 2 servers. So by default, server 1 communicates with server 2, and server 2 tries to get the Google page, essentially. So we want to see that when we execute server, or we target, we do a HTTP request against server 1, then server 2 should be down, essentially. I'll keep coming to this interesting realization, especially being at different hotel hi-fis and so on, that the more we want to be online, the more need we actually need to be offline. Because trying to get something done on a slow network is pain in the ass. So let's look at that as far as the runtime goes. So in the first example, it's just going to do the call as it would normally, with no extra stuff that's being injected. And then in the second attempt, we're going to make sure that this server 2 is down, essentially. And yeah, we just run that now. And it starts up 2 different server, or the 2 different servers that we define, and then it adds on the toxic proxy to proxy all the information through. So this is the original configuration that we gave Cube, which is our server 1 on 8085 and our server 2 on 80. And then when Cube Q comes along, it rewrites that configuration on the fly to say that instead of linking server 1 to server 2, it's going to link to the toxic proxy, and same with server 2, it's going to go through the toxic proxy, and then the toxic proxy essentially ends up getting all the different ports in and out, and it will register. So I'm not sure you see that. Yeah, it will register that there is a route going from server 1 to the toxic proxy, and one from server 2 to the toxic proxy. So the external port that we're now actually communicating with is the toxic proxy, and that's sending it to server 1 on 80, and then that's going back to the toxic proxy, and then going over to server 2 again. And with that, you can have much fun. Essentially, the options so far are bandwidth. You can limit how much data is being sent. You can make sure it's down. Yeah, you can slice up the packages and so on. Oh yeah, we got green bars again. And that should have removed all of them. Yeah. So that was essentially what I had as far as demos and far as talking goes. Any questions at this point? Yes. Which parts of the freely? Oh, which parts of them are freely available? Arquillian is an open source Apache 2 project, so everything. Yeah, and I'm Aslak Knutsen. I'm the Arquillian project lead. If you have any questions, you can contact me on Twitter, on GitHub. Yes. You do it exactly the same as you would any other test. Oh, right. So there's do you need? No, you don't need Docker on the machine that you're running it from. Technically, if you have if you have a remote Docker host somewhere, you just define the server host and IP, and then it could communicate with that. Or optionally, if you have a Docker machine that is installed on the test machine, then that machine could technically be in the Google Cloud or any of the other Docker machine supported deployment options. If that's answering your question. You mean without using the Docker stuff? Is that what you? So your tests are running in the Docker container? Huh. Um, good question. Technically, yeah. Due to Jenkins integration, Arquillian Cube should be able to run Docker within Docker. So if your container, if you deploy a container with all your tests in them and run that container, then that could be another test suite. Yeah, that should work. Yeah. Anyone else? No. Well, then we close early instead. That's good. All right. Thank you.